Okay, applications of radicals is just, I don't know why this is so out of focus. Still kind of out of focus. A little bit better. So this is just taking, hi guys. Okay, this is just taking word problems, taking everything we know about radicals so far and applying it to a word problem. You need to know, sometimes it'll talk about like area, and so you have all the area formulas, well, most of the area formulas on your formula sheet, so you can use those if necessary, but we're just going to dive into this because this is no new stuff, it's just applying it in a different way. So an artist creates a pattern similar to the one shown, but he frames the equilateral triangle. What do we know about equilateral triangles? All the sides are the same length. What do we know about the angles inside of equilateral triangles? Nope. You're right with they're all the same. And what would it be? 60, because they all add up to 180. And if they're all the same, then we just take 180 and divide it by 3. So we know lots of stuff already about equilateral triangles. And cheese. We know lots about cheese. Inside the square, so in this pattern, we have a circle with an equilateral triangle inside of it. Now we're going to have a square with an equilateral triangle inside of it. So you're going to end up with I'm going to do my best to draw this. So I know it's really good cheese, but if we can just do the math. So you're going to end up with an equilateral triangle inside the square. Now, there's a couple of things that we know that we don't know. We know that it's a square. So what do we know about all the sides? They're all the same. Proud of you guys. Okay, see, so we know lots of stuff. We know the area of the square is 32 centimeters squared. How do you find, if you have your formula sheet on you quick, how do you find the area of a square? Okay, so area is length times width, but there's something special if it's a square. What do we know? They're the same. So you might see it written as side squared. So it might say side squared instead, just because they're not identifying it as a length or a width because they're not different. That's going to come in handy in a few minutes. What's the exact perimeter of the triangle? Okay, so here's my pretty picture of what we got going on here. If we know this length, what do we know about this? It's the same, correct? Those two things are the same.
How do we know what picture to draw? Like, how did you know that the triangle didn't touch the top?
It might touch the top. It won't affect anything. Like if I drew it with, but what I do know about hypotenuses of a triangle, what do I know about hypotenuse of a triangle?
90 degrees, no way.
So if I made that a 90-degree triangle, and I'm looking at this, what do I know about hypotenuses? Tell me about hypotenuses.
A squared plus b squared.
Okay, good. A squared plus b squared equals c squared. C squared being the hypotenuse. What do we know about the hypotenuse? It's the sum of the square of the two sides. I'm just trying to get the easiest thing. When I'm looking at the three sides, which one's the longest? Hypotenuse, right? So I know that the hypotenuse is going to be longer than this side here. So I know that the tip and the base can't, like one can touch, but not both can touch. But it won't affect your math if you drew it this way. Like, because you're going to make some assumptions and your drawing won't be to scale and we'll be all fine with that. Okay, so what's the exact perimeter of a triangle? So what we know, it's given us one number, 32. So we know that the area of the square is 32. It's really out of focus. Is this out of focus for you guys? Or is it clear? It's pretty clear? Okay. It's really out of focus on my screen, but I'll get over it. And you're like, but the question is about the triangle, Miss Gallion. But you guys told me that if I know the side length, I'm going to know the base length of the triangle. So, and how am I going to solve that? I'm going to square root everything. Can I simplify that? Yeah. 16 and 2, right? So I'm looking for the factors of 32 that have a perfect square in them and a big perfect square. Like 4 works, 4 and 8, but I know I can break down 8 into 4 and 2 as well. So I'm going to go 16 and 2. And if you're still not comfortable with that, I would encourage you to keep practicing, like look at numbers, start thinking about them in their factor pairs. What does that look like? So that's my side length of a square. That's my side length on the square. And we said that the square, the one side of the square would match the base of the triangle. Didn't matter which drawing you used, it would be the same. So if we know that this is 4 root 2 right here, what is the perimeter? How do we find perimeter? Sum of all sides. So we're going to take the perimeter, and we said it was an equilateral triangle. So what do we know about all sides? They're all the same. So I'm going to take 4 root 2 plus 4 root 2 plus 4 root 2. And we all know that triangles have 3 sides? Yeah? Okay. Just like to double check. And so when I'm adding up radicals, what do I do? Add the coefficients, keep the radical. So we're going to have 12 root 2, and then I need a unit of measure on it. Centimeters. Okay, part B, what is the exact height of the triangle? Okay, I want to talk a little bit about language in math here. I didn't kind of highlight it in this one, but it's talking about exact perimeter, exact height, exact area. The word exact means that you are going to leave it in radical or fraction form. You're not going to convert it to a decimal. So anytime I ask for an exact value, I'm looking for no decimals, no rounding. You're going to either leave it as a fraction, a radical. You're not going to do any conversions, okay? We're going to use that language a lot throughout this class and 12 when we make it there, but not today. We're not making it to grade 12 today. We just had a conversation in calculus. One of my calc students used the first derivative to find the secret formula, which was super cool. So the secret formula for finding the x-coordinate of the vertex, it's just a derivative. And it was so cool that he made the link between the two. So you guys just wait till grade 12. Some of you will be in my calc class. It'll be super exciting. Negative b. Negative b divided by 2a is the secret formula. I think you're thinking of the discriminant, which is the b squared minus 4ac. Oh, so he figured out how that formula actually works and where it came from. Okay, determine the exact height of the triangle. All right, so there's my triangle. I'm looking for the exact height. When you guys are asked to find a height, you're looking for the vertical height. So that's a direct, like, up, down. We're not looking for the side length. That's not a height. It's this dash line here. So what we essentially did is we just cut our equilateral triangle into 2 right triangles. So I'm just going to redraw this. a little bit bigger. We know that all equilateral triangle sides, so the hypotenuse would be 4 root 2. What do we know the base is? Half of 4 root 2, so that would be
2.
right? We're taking half of 4 root 2. So that's going to be 2 root 2. Okay, remember that Pythagorean theorem we just did? We're trying to find that side there. Now you could use right angle trig because we know all interior angles are 60 degrees. But the trouble is as soon as we use our calculators, that's going to give us decimals and rounded answers that won't be exact values. So we got to pull out good old Pythagoras. A squared plus b squared equals c squared. And we know, I'll say we know a. So a is 2 root 2 squared plus b squared equals 4 root 2 squared. Maybe I just need glasses. Maybe that's my problem. Okay, so we did this yesterday. When we square a radical with a coefficient, what do we have to do to that radical?
Square.
We have to, sorry, I said radical, but I meant coefficient. We have to square the coefficient, and that square is going to cancel it, the root sign. So that's going to be 4 times 2. Okay, I don't want b squared, I just want b, so I'm going to square root. Square root, b is equal to root 24. Can I simplify 24? What factors? I know 4 and 6 work for sure. Is there anything bigger? Does 9 go in? Does 16 go in? No, and then after that we're too big, right? We're at 25. So 4 is my only one. Okay, can we do cheese deals later? Oh my God. Just put the cheese money away. Cheese is taking over pre-cal. All right, letter C. Area, what is the exact area of a triangle? Aaron, did you still need that? Did I move that up too quick for you? No? Okay. Okay, how do we find area of a triangle? Area is equal to base times height divided by 2. I do think that some of these formulas are stuff that you probably have been exposed to, but probably haven't used in a little while. But knowing this stuff is handy. It is on your formula sheet if you need to find it there. So what do we know about our triangle? We're going back to our equilateral triangle. We're going back to this one. So what's our base? 4 root 2. Now what's our height? 2 root 6. It's the one we just found. Anytime we're talking about height, we're talking about that vertical height. Okay, how do we multiply these? And then radicals, right? So we have 8 root 12 divided by 2. So that's going to be 4 root 12. Can I simplify 12? Mm-hmm.
4 and 3.
Yep. And I always like to write that 4 times 2, just because I find when these two numbers are the same, we end up losing something. We end up losing like the rooted 4 or the regular 4. When the numbers are the same, we tend to lose them. And it's a centimeter squared because we're dealing with area. So none of the math was hard on there. I think some of the math was hard to get your head wrapped around. Like, I'm not sure you would have intuitively known how to find the height of the triangle. That might have been, the process might have been hard, but the math wasn't. Okay, so here's my problem. Oh, what did we do? There was an accident that we're not talking about. Was it your fault, Vishwa? Probably. Okay.
My God.
Hey, what did I say? Cheese deals after the lesson. Okay. Do you need a new book? Was there an incident, Aaron, that you need a new book? We have extras. You sure? All right. Okay. So this question is unfair. You wouldn't be able to do it because you don't know what the exact value of tan 30 is. I do, and you will in grade 12, but we don't know that yet. But if I told you this, if I told you this, then you could do this question. And you're just, for right now, I'm going to ask you to trust me with this. We're going to learn how to figure this out in grade 12 when we're doing the unit circle. So if you want me to explain it to you, then we can, but it's going to take some time. We'll hold off till grade 12. When I make you cry anyway, generally on this unit, you'll be fine. Okay, so if you know that, can you find the distance across the ramp or across the base of this skateboarding ramp? Okay. So the reason why I gave you tan was for a reason. Yeah. Sure. No, you gotta lay them, yeah, get them perpendicular. No, perpendicular first. Everybody's like perpendicular. Oh, perfect, good. That's good enough. That's good enough. Now use the white cord to close them. Yep. No, you gotta pull on one string on the side. Okay, other way, yeah. See, we're getting there. It's a learning experience. Now you use the silver cords again to make them close. Okay, for the record, that was pretty awesome. That blind in the middle there, I don't know what goes on with that. That's just who that blind is. Okay, so orange triangle. You're going back to trig. You're going back to trig, basic trig. I want to find, on this orange triangle, I want to find x. So this is my opposite side. This is my adjacent side. The trig formula that contains opposite and adjacent is?
Wait, how do I find?
So we're going to use the tan formula. Tan of the angle is equal to opposite over adjacent. So we are going to have tan, of 30 degrees is equal to the opposite side, which is 40, over the adjacent side, which is x. Now, I told you that tan of 30 is equal to 1 over root 3. You wouldn't have been able to do that question without that little tidbit of knowledge. Okay, I'd like you to solve for x. I'm going to leave you to your algebra. Okay, how did your algebra go?
Pretty good.
No?
Did I have to do like the reciprocal thing? Flip flop?
Some people like to cross multiply, but I don't ever like to teach it that way because it's only limited when there's an equal sign in between them. I'm going to times both sides by x.
What the hell? What's she doing? Oh.
Okay, so I wanted to eliminate the x off the bottom. And now I have x, but it's divided by root 3. What's the opposite to divide by root 3? Times by root 3. Those cancel each other out. And when I say cancel each other out, it's not that they have a value of 0, but something divided by itself is 1. And then when you times x by 1, it's just x. So when we say the word cancel each other out, some people think like, oh, it's 0, it doesn't matter. Well, that's not a true statement. So that's the math behind what I did. So if you weren't sure how to tackle it, cross multiplying, when there's one fraction on this side, so if I have 1 over root 3 equals 40 over x, one fraction separated by an equal sign, multiply those two, and then multiply those two. That's a lot easier math, but it's like a trick. It's not the actual math process. But I think if you understand this, the full process, doing it quickly isn't a bad thing.
What if you just flip flop x and 1 over 3?
You multiply by the reciprocal?
Yeah.
But what did you do with the x?
Like if the x is at the bottom, you just,
You cross multiplied.
I guess.
Yeah. In your own way. Okay, now you guys armed with that knowledge, armed with all that special knowledge, I want you to do that same process again, but on the purple triangle this time. Okay, have I answered the question yet?
No.
What's the question?
What's the total length of the bottom? The base?
So what do I need to do with these two things? Add them. So the base is how much? Can you do that in your head?
Yeah.
Yeah. And what do I need on that?
Units.
Which is? centimeters. Okay, so again, not super hard math, but we had to think about some stuff. The speed in meters per second of a 0.4 kilogram football has a 28.8 joules of kinetic energy. Use kinetic energy formula given here. Energy kinetic is equal to 1/2 mass times velocity time squared, where EK represents the kinetic energy in joules, M represents the mass in kilograms, and V represents the speed in meters per second. I said velocity. They're saying speed. What's the difference between speed and velocity, you physics people? Velocity is vector, it has direction, right? So it could be a positive or a negative. Speed is just the positive one of it. It doesn't have direction. Okay, so really what we're doing, this is a plug and chug. These are my favorite, easy things to do. So we know the kinetic energy. So EK equals 1/2 mv squared. So we know EK was 28.8. Now, does this say exact value? Does it say exact value in here anywhere? No. So do I need to have a radical in my answer? Nah. Okay, so 28.8 joules of kinetic energy is going to go in for the E. How much does the football weigh? And we're trying to find what is the speed. So we're trying to solve for V. Oh, does anybody see what 144 is? It's a perfect square, right? 144 is perfect square. But 12 what? Meters per second. It's given in the equation here. That one was, I call those plug and chugs. It's just using algebra to solve for an unknown variable. Didn't require any mathematical thinking in my brain. Well, it did, but not too much. So this lesson is just going to be using all your math knowledge and your radical knowledge together. This is the end of chapter 5. The end. But what?